Assalamu alaikum. Now I will be explaining the method to solve this example 4-2 graphically, and the statement for the problem is given here. Given a 4-bar crank slider linkage with the link lengths as stated here, that crank is 40 millimeter and capital link or connecting rod is 120 millimeter and offset is C minus 20 millimeter, and for theta 2 20 degree. This is the input location. Find all the possible values of theta 3 and theta, and the slider position D because it is the output. The method to draw graphically will be explained using Microsoft Word as previously, and after completing the position diagram, we will be measuring the respective angles or requirements with that position D, both possible positions of the slider, and then we will be performing the velocity analysis graphically. So as first of all, our task will be to select a suitable scale or suggest a scale. So here the largest dimension is also 120 millimeter, as we can observe. So we can select any suitable scale. For example, at this stage we can suggest, for example, 10 millimeter is equal to 1 centimeter. For example, 10 millimeter is equal to 1 centimeter. So we can do it on a fresh page. Sorry. Here we will be starting from the input location O2 as it is given. So we will be drawing a random vector A at random location here, and as we can observe from the statement that theta 2 is 60 degree and the crank length will be 4 centimeter here. So we can bring this scale on next page, and also we can move this protector on to next page. Now we will be placing this protector, or we can resize it as well, or I am zooming in for a better view here like this. We can use this up and down arrows for better positioning, and now we will be measuring its length. We will first of all be placing it at the 60 degree, and it is at 60. This is the 60 degree line, and now we will be, this must be 4 centimeter. So we will be moving this scale and bringing it, its edge we will be placed along this vector like this. Here like this. So here we can see that 1 2 3 4 and 4.5, so we can increase it to exactly 5 centimeter. like this. So in this way its length has been specified to be 5 centimeter. Sorry, uh, uh, because the crank is 4 millimeter, so it is 4 centimeter. Sorry, so we can reduce it to 4 centimeter. So here we will be carefully placing this at the 60 degree line. We will be moving this end at exactly at the 60 degree location and 4 centimeter here. Very carefully. Like this. So now we can move this scale and the protector out, and after that we will be specifying. This is actually the point crank pivot, which is actually 0.02. so we can copy it from another diagram just to save time. Here we can copy this tag and we can move it here, and furthermore we can again copy for point A and we can change it. We can type it here point A and we can place it here. So point A has been marked. After that we will be drawing some horizontal references so that proper origin can be placed here like this. And because this is the reference, we will be changing into some other line pattern. Here we change dash pattern here like this. This is our global coordinate system or x-axis, and this vertical will be the y-axis. So we will be making it by observation to be exactly horizontal. So now we will be drawing the reference lines for the locations of the slider. So we will be determining the offset, as the offset is actually minus 20 millimeter. So remember that, for example, this is the x-axis line. We can type, or we can just copy this label to for example we can write it here x-axis, and we can also for example draw a vertical reference line here at this location, a random arbitrary line, and again we can change dashed pattern like this, and we can again type it to y, capital Y, global coordinate system like this, and we can place it at here for example like this. So x and y has been defined, and after that we will be the offset will be below this x-axis line. So we will be drawing another reference line, or we can just for example we can copy this line and we can repaste it, and exactly below it its length that does not matter, and we can extend this vertical line below. And according to scale, for example, we observe that this vertical gap must be 2 centimeter, so we can place this scale and at any suitable location here, and like this, sorry, exactly horizontal, or and like this. So this is 1 centimeter, so here it will be 2 centimeter, so we can move it down at 2 centimeter location like this here, like this. So it has been specified 2 centimeter. So this is the slider line. So now we will be moving the scale out, and now we will be drawing a circle equal to the length of connecting rod, and that circle will be drawn at by placing the compass center at point A, and we will be drawing a circle or an arc of radius equal to the connecting rod length, which is actually B 120 millimeter, and that line circle will or arc that will cross this offset line, because this is the slider axis. So to draw the proper circle, we can actually first of all resize this protector, and we can also put this in landscape mode, because we have selected or chosen a larger scale, so we can put it landscape mode like this. So we have put it in landscape orientation for better view. In landscape mode, it is not clear, so we put it in again portrait mode. Here like this. So what we can do now, we can move it a bit down, so that protector, now we will be resizing the protector so that it's the radius of this protector becomes equal to 12 centimeter, 12 centimeter, because the 10 millimeter is equal to 1 centimeter. So we will be moving this like this, that so we will be again resizing this protector like this, and we will be moving it again at the 0 line, and we will again be resizing it here. As we can observe that this is again we will be repositioning it. Here like this. Here, so this is now equal to 12 centimeter. The radius of the protector is 12 centimeter. So at this stage now we can draw a circular shape or we can just draw an arc having radius exactly equal. So here like this. So we will be making sure that this arc is actually crosses this horizontal slider line. Here like this. Making this intersection with the help of this arc will be rather difficult, so we can use this ellipse shape. So this circle can be resized and we can shape it no fill so that the back view is clear. And here like this, as we can observe, this has so as we can observe that the circle of 12 centimeter has been drawn, and now we can resize this calculator and move it out. here like this. And now we can extend this slider line so that it can intersect the circle here, and now we will be placing this vector here, and we can draw or insert a rectangular shape just to represent the slider here like this. This is a random box, and we can no fill it so that it is clear. And now we can change their colors. So in this way slider location and length has been, and here we can observe that this length must be 12 centimeter. That we now can again verify it by placing the foot scale here, aligning along this vector very carefully, keeping it parallel, moving, and here we can observe that it is 12 centimeter. So in this way, and again we can verify that the offset, this vertical offset between the slider line is 2 centimeter as it can be seen. So everything has been drawn. Now we can move this scale we can move this scale out, and we can further label this diagram. We can copy this label for labeling the slider like this. We can move it here, and this is actually the point B, which is actually the slider location for first branch. So in this way this point B has been specified. Now we will be measuring the angles, but before angle we will be also drawing its crossed position. So to draw the crossed position, as this circle is not in the complete view, and this is out of size, so we will first of all be moving this slider and complete diagram in the right orientation, so that we because we have actually unfortunately selected a larger scale for better view, or we could zoom in, but I have selected a larger scale. So here important learning point that we will be seeing that how we will be moving this complete diagram using towards right. So we will be selecting this slider box, and then we will be pressing Control button from keyboard, and then as the plus sign here it appears, just we are hovering our cursor. So we will be selecting these multiple objects, multiple shapes, and without selecting these labels will later be moved separately. And also we can click on this outer circle as well, and now we will be clicking on the this right arrow from the keyboard, and as we can observe that this diagram is moving towards right, and we will be moving it maximum as possible. As we can observe that the circle is now clear. Now we can move these labels a bit at proper locations like this point A at its proper location here, and again this slider B at its location here, and this x-axis here at this location, for example. Now we will be extending the slider line, slider axis in this orientation as well, maintaining its horizontal orientation, and it is also intersecting this connecting rod circle at this location. And now we will be inserting another arrow symbol for the connecting rod here, and here the intersection. So this is the slider position for the other branch number 2. This is branch number 1 of the crank slider location, and this is the second branch. And we can, for example, copy the same slider and we can paste it here. We can move from here this copy and we can paste it here, so that identical sliders are created. So in this way, now we can change its color to some, we can keep its color as original, and we can change its color to be different for this circuit, because this is the main or branch 1 circuit. So in this way, now we can again verify that the length of this vector A B dash, so this is the B dash location. We can copy this label as well from here, and we can type here, this is actually we want to copy this tag. We can copy and we can paste and we can move it here, and this location is actually B dash. So and we can also mention here the offset 20. We now just label this diagram so that it is clear. We can copy this label and change it at various locations. We can make its copies here, and then we will be changing it. So for example, this length is actually B, which is equal to 120 millimeter. 120 millimeter, and Similarly, we can this crank is actually equal to denoted by A, and this is equal to 40 millimeter, and we can resize this box so that it is clear, and we can do auto capitalization, and we can also change this offset, label this offset as well. So we can use, for example, these double arrows like this. So this is the offset, or we can also change its outline pattern as to be dashed pattern. So we can again, for example, copy this label to place, and now we can write it here. Offset is equal to minus 20 millimeter, and then we can resize it as we can observe. So this offset has also been shown, and now we can also show this slider location horizontally. So we can, for example, copy this label and move it here, and again we can use this double arrow sign from here to this slider joint center line here like this, like this. So this is equal to, as it is mentioned here, that it is not mentioned here, and we will be actually measuring it using the scale, and we can verify it whether our results are correct or not, or how much is the variation. So now, as we can observe, we can a bit align this scale here, and now we observe that this slider location this slider placing this scale actually that requires exercise, and so here like this, for example. Approximately That may be due to that maybe this line may not be exactly horizontal, so that could be the reason. In order that we will be verifying at two locations that this must be 2 centimeter exactly. So here, as we can observe that this line is, this must be here. So like this, we can move a bit down here and we can measure at this location that as we can observe that this end is above, so we will move it here like this. Now this scale can be moved here like this. So this will give us actually the approximation very carefully. Sorry, this requires a lot of effort. Here, now it is approximately. So this is equal to, here it comes that 13.2, yeah, means 132 millimeter. So here we observe from the solution that here the dimension is shown 126.84. so there is slight variation, so we can check from the diagram if we have some discrepancy. So as we can verify again the length of the connecting rod here like this. So as we can observe that this is actually 12 centimeter. Here this is 12 centimeter, and now we again we will also have to verify the crank angle again, and that was stated as to be 60 degree. So we can also verify that angle as well, if to check if there is some discrepancy. And as we can observe that this line is not exactly horizontal, we can move it a bit down with the help of, because this must be on 0 0 line. So this is now exactly horizontal here like this. So now as we can observe that the angle is exactly 60 degrees approximately, so the angle is quite okay. So now we again moving this scale and again measuring the slider location. Again we will be first of all verifying this 20 millimeter offset. Here, as you can observe, this line is a slider line is not at proper location. Not at the proper location, so it must be here. So this is this is now seemingly 2 centimeter exactly, and now we will be moving this scale and again will be verifying from here, and as now we can observe that here 125 and 126 127, so our results are matching this approximately 126 127 millimeter. And remember that in the graphical working and task there is always 10 to 15% discrepancy allowed, and that doesn't make any difference if the method is correct. So here we can mention the slider location D1, for example, D subscript 1, which is equal to 127, for example, 127 millimeter we can assume as we have demonstrated, and like this. So, and again in a similar manner we can calculate or measure, we actually measure the other location of the slider. So we first of all verify the offset at this location as well. This location as well. We can first of all verify the offset at 2 locations. Here, as we can observe that the offset it shows 2 centimeter, and here it also shows somewhere 2 centimeter, so it is okay. We just measure the location of this B dash position of the slider, and as we can observe that this is equal to somewhat 85 86 87 88 somewhat 88 millimeter per second, and as we can observe that here it is written minus 86.4. so our results are quite similar and near to the theoretical or analytical results. So we can, in a similar manner, we can copy this label on this arrow here at this location. We can resize it, and now we can copy the same label at this location here. For example, we can move it now and we can graph, we can just type it to be approximately equal to, for example, 88 millimeter, and put the negative sign because it is along the negative x-axis direction. So in this way the positioning diagram has been completed. So this is the method to solve it graphically. Now we can also verify the angles. So bring the calculator and measure the angle like this. So here at this location, carefully place the slider center line. And here we can observe that there is a bit compromise by noting. So as we can observe that it is 10, 20, 10, 20, 25, 26. So this is somewhat 26 degrees, and we can observe from the diagram here that in the counterclockwise orientation the angle is 152.91, and our angle, this internal angle, is 10, 20, 25, 26. So we will be subtracting this 26 from 180 degrees, for example, and as we can observe it is 154. So our results are quite near. This is 152 in the counterclockwise orientation, and our angle in the clockwise orientation, this is, so our angle is also quite near. So this angle has also been verified. In a similar manner we can verify this angle as well. So we can also visualize this angle, and this angle is 10, 20 and 25, 26, 27. So this angle is also mentioned here, 27.09 degrees. So these are actually the analytical results, and our results are quite near. So this is, so slider location and the angles have been quite satisfied. We can just mention them by drawing simple arc as the angular notation here like this, and we can now mention it at any suitable location here like this. Like this, and another arc for as angle representation at this location. Here we can rotate it like this, and just we can place it here like this. In this way, so now we can copy any label and mention the angular values. So for example, I can copy this tag from any picture, and we can paste it, for example, as many times as required. So now move it here, and this is actually, this is approximately 27 degrees, and another value here as we have observed, this is also equal to somewhat 26 degrees clockwise, and this outer angle is 152.9 degrees. So in this way position diagram has been completed. Now in this way, after completing the position diagram, we can remove this circle or only keep the required portion of this circle, which is actually intersecting the slider axis line. So this is the slider axis line. We can label it as well for reference. So we can call that this is actually, this line is the slider axis. So we can type it here. This is actually the slider axis. So slider axis has been specified like this. So this is the slider axis. Now we can, if we want, we can remove this circle for better clarity, but we will let it remain in order to explain the methodology. So in this way this position diagram has been completed. If you have any question, you can meet and personally ask me. Thank you and Assalamu alaikum. Jazakallah.